not that you've asked, but we are rolling. Any questions? Okay. We did the plus minus 0 yesterday, if I recall correctly.
Yeah, plus minus 0.
Yeah, you want to walk back and forth?
Oh, yeah.
Oh, yes, yeah.
If in doubt, just read my mind.
Should try that.
Stay away from dark areas. All right. So we have position. Really crappy marker. Displacement. Velocity. And acceleration. All right. A ball is going to be thrown straight up into the air and come back down. It's potentially be very quick if you watch the video, or if you haven't watched the video, then you get to experience the joy. I'm going to label specific parts in this. Time, these are times, time A. So the time starts just after the ball leaves the hand. So the person is irrelevant. The person is there just for a backstory, but the person picks the ball, throws it up into the air. And so time begins at time A, just after the ball has left the hand. So small little erase there just so that they're disconnected, so that's A. B is the time ball is at peak. Time C, time ball is back at same position as at time A. So let's see, and then D, time just before the ball touches the ground. So 4 moments in time. So D. Just so that we are dealing with common notation here, I'm going to make up positive, and I'm going to make the ground the origin. What I want you to do is determine when is the position positive, negative, or 0, when is the displacement positive, negative, or 0, and so on. We can present this several different ways. So one of the ways I'm going to introduce now to present it comes from the math notation. So if something happens from time A to time B, including at time A and at time B, you would write it as A, B. So this means from A to B, including A and B. So everywhere from the moment that it has left the hand to at the peak. If I use a parenthesis, so A comma B, this means from A to B, including B, where I've got the square bracket, but excluding A. So parenthesis means I'm not including that endpoint, the square bracket means I am including that endpoint, and if something happens at just point A, I would just write A. So this is only at time A. Now, recognize the different time periods we're dealing with here. There's time A, there's between A and B, there's time B, there is between B and C, there's time C, and between C and D, and at time D. So I have 1, 2, 3, 4, 5, 6, 7 different time periods. 4 of them are specific limited time, and the other 3 are in-betweens. So if anything changes for positive, negative, or 0 to positive, or whatever, it will happen during one of these 7 segments. Now, if something is happening from A to C, let's say including A and C, you don't have to write A to B and then B to C. You can just write A comma C, and that covers everything from A to C. All right. Questions about any of the words I've written over there? Questions about what the problem is? Or what's happening in the problem?
Will there like be a starting point necessarily, or is A the starting point?
The problem starts at time A. The problem ends at time B. All right. And what your task is to determine when the big 4 quantities, when are they positive, when are they negative, when are they 0? If they are not, so if it's never, if position is never positive, then you would just write in/A or something like that. Let me set up the chart there. So position, displacement, velocity, acceleration, positive, 0, negative. There are other ways of presenting this information, but one of them. So if this is never positive, you would just write in A, just as a matter of habit. Leaving it blank, sometimes I'm confused whether the student had no idea or whether they were deliberately leaving it blank, so that's why something goes there. Abigail, you have?
Would this look like something like a question on a test or something?
This is
Similar?
the basics of a question that will be on the test. After this one, when we've discussed it, then I'll do a test level problem.
Okay.
Actually, if you look at some of the old tests, you might see something like this, but then it just getting more and more sophisticated. Complicated? No, let's go sophisticated.
Better.
Yes, faster, stronger. I have more faith in the students. All right, I will give you a chance, and feel free to work with someone. You don't have to do it completely solo, but I will give you 10 minutes to try to figure this out. Discuss it amongst yourselves if you wish, and then we will talk about it as a group. And just because of the sheer excitement of having you work behind the camera, I'm just gonna let it roll.
Robin, come here.
Still a little Adam.
Also, I couldn't add you to the chat because I don't think you actually accepted the request. Oh, well, they chat.
If you would like, this looks familiar.
Like, we're figuring out when all of the things are positive. They're in one position between displacement, velocity, and acceleration.
It's just as a reminder. Where object
This
is
is a reverse Schwartz prediction.
with respect to origin.
Velocity acceleration.
Yeah, when they are positive and
position is positive from bracket A to parenthesis D.
Yeah, cause it's the origin
The D touches the,
behind the guy, so it's building.
How fast?
so the ground is the origin. Throw it, it's already above.
Yeah.
But as soon as it touches the ground.
I was going straight up and straight down.
Yeah.
Oh, okay.
So D is the is the
Just
but
up to the
be
ball.
anything like 0.001 that's also positive. So
Yeah.
It's not like it's going through the ground.
and then for displacement.
So do we have to do that graph for every single one for each?
Maybe. I'm not.
So, Adam, what's happening here is similar to yesterday, I was going back and forth in front of the board. This one, we're just dealing with a vertical problem. Origin, up is positive. I have these 4 moments in time, and you need to determine when. These 4 characteristics, when are they positive, when are they negative, when are they zero?
Parentheses first.
Exactly.
Because as soon as D touches the ground, it's already zero. So
No, D's before it touches the ground.
is it? Oh, before.
Yeah.
I said it's as soon. Okay, there you go.
So we're supposed to be filling in like.
That's why you read the
So
question.
say A to B is.
Is this a
My
question
comment is
or?
there.
Position.
No, I-
B
Are you asking more about
is
that?
B.
Oh, no, I'm taking-
Okay, all right.
The position.
Oh, okay, I see what you mean.
And then
Wanted to be sure.
C would be-
B is
or B would be-
What? No, before.
Does that make sense? So you're kind of filling it in because the top of the, table set is positive, zero, or negative. So
Are
you're
you
just filling in.
talking to me or her?
Yeah.
If any of those things, like, so you would do like A to D or B to C or whatever, if that makes
D is
sense.
right
And that's
before.
the second one too, like
So then its position would be positive.
So it's like, it would be position displacement velocity.
For the 7 time, so you have
So.
the 4 exact
like,
times.
Whether or
and
not
you have
their
the times
position
in
be
between.
positive,
So
negative, or zero.
during this week, from,
Acceleration after.
so at time A, is this, which of these are positive, which are negative, which are zero? Between A and B, which are positive, which are negative.
It's just like.
And, yeah, the ground is the origin.
Okay, and A would be starting.
A is the starting point.
Okay, so
Or the ball was at the starting point at
If
time
it's
A.
positive or negative from when, so position is positive from when.
Position depends upon where the origin is, and so that's why I defined
That's
it.
the
If I did not do that, all left it up, we potentially would have a dozen different origins.
Okay.
Okay,
Okay, I
so
understand.
there's 7 places that we
I get it now, so I'm just filling in that.
Yes.
Okay,
So this
that's what I wanted to
one
make sure,
positive.
because I was like, I
Two,
drew one.
right?
Positive only after from A to C and then from C to D is negative because your origin is U.
Yes.
It's a starting point. No, I'm getting checked
Well, no,
out.
that's a starting, okay.
Yeah.
If that's the starting point.
Now I'm getting velocity
To the starting point, yeah. So A is the starting point. D is below the starting point, so it's negative then.
Alright, now I got stuck at velocity and acceleration. So I know from A to B is positive, B to D is negative. But what is the velocity at point D at point B exactly? Is that gonna be 0? I'm sorry.
Positive from negative A to C parentheses
For what?
for this one.
Yes. Because as soon as you hit point C, you're at 0.
Yeah.
So,
So that would be parentheses or bracket?
For the positive, it's gonna be a
So wouldn't the
parenthesis.
position that you're
Yeah, the position would never be negative because you're always above the origin.
oh, I thought you were, I thought that was the position for someone.
Yeah, because it's at the position before the ball touches the ground, so it never touched the ground. If it's at time when ball touches the ground, then that would have been a bracket.
let me see if I have the.
So this position is positive, like from A to B, right?
Both brackets.
I don't know what to put for D for acceleration. I know for acceleration it's going. Wait, hold on. Okay, finding the
This
reference.
position. It should be a position positive.
I'm trying.
A to C, negative.
acceleration.
Yeah. Yes.
Oh, wait, no. There's a word D. No, I'm right. Yeah.
Okay. Okay, find the derivative of b. So if it's
Found the home.
oh no. So at that rate, okay, so acceleration for b is 0 because it doesn't have a rate of change. So b is 0 for velocity because it's okay. So the change in velocity over time is acceleration, correct?
Time rate, change on velocity, yeah, acceleration.
So the rate of acceleration at a parabola, which is the peak is at 0, so that has to be 0 on b for acceleration, and then the rest should be negative all throughout after
Yeah,
b.
if, the velocity is constant, that means there's no acceleration or something, right?
But like now, what is velocity at b? Because
Oh, that is a change, it's not a constant change, right? There was something.
wait, it's
The
negative.
acceleration is constant, right?
What?
For velocity, if you're moving this way, the ball's going out, and then it stops, and then it goes this way.
It never stopped. Think about it.
I guess it
So
does
like,
never stop.
so you just go up, but it slowly, it starts to slowly increase, and it just decreases.
Yeah,
So like a
but at
point
some point, it will momentarily stop.
for a very, very millisecond, but that's somewhat negligible.
I think that counts. I'm pretty sure we talked about yesterday that
No, I
counts.
thought it doesn't. I forgot. I don't know if I was. I know when you stop moving that 0, but I know if you just stop moving for a few seconds because I remember
Yeah,
talking.
there's a difference.
Yeah, because I remember talking about like if some. I know. Yeah.
Okay, this is off topic, but for change for the displacement, do you just write the line or is that 0?
Yeah. So like, I forgot which one, but he said like when you throw the ball something, it's just going to suspend the air for like a whole second, right? It's just gonna keep decreasing. But is that for acceleration or
I
velocity?
think he said if something is moving and it stops, but then stays there, the acceleration would then be 0.
But the velocity will just decrease.
But it's 0, so you still have to, it still counts.
Yeah,
0 still counts.
but it's only 0 if it goes up and then stops.
Yeah,
I
but it
think-
never stopped.
Yeah, so it's
We're
going
talking about acceleration.
Yeah,
Oh,
acceleration.
yeah.
Acceleration just zeroed on B, right?
The acceleration's always.
Yeah.
Because
Right, because velocity is positive, so.
Because it's slowing down all the way until it reaches point B and then it starts speeding up again.
Yeah.
can you velocity got me. It did change. Did it change?
Because it's going fast.
Did it change direction on B? Would you consider that a change of direction? I mean, they changed it at the instant of B, right?
Yeah.
So do you consider it as a change in direction just going up or changing direction and going down at the instant point of B?
It's going, or so far acceleration.
For velocity.
But for velocity, yes, there's a change in direction.
The constant velocity acceleration.
Velocity is positive from A to B, negative from B to D.
I think I got it. It's just velocity got me.
Yeah.
Because thank God I took calc.
Not very often since.
I know. I despise calc so much. It's just I don't know if you would consider B a changing direction already, even though it went suspending the air.
Yeah, but even if it's not changing direction, it's slowing down.
It's slowing down
It's slowing down and then
in
speeding
the
up.
negative direction. So would you is that change negligible or would you consider that a negative number? Because if it's
It's definitely not. Because it's like speeding up and slowing down is what acceleration is. So that's
Yeah.
what we are looking for here.
because to the right of the B it's still positive.
That's what
It's just positive.
yeah, you
positive, zero, negative.
Type everything.
Yeah,
These are.
Yeah.
Right. Okay. We need to think about it like a function. You can't go from okay. So for a velocity, the fastest time it will go is as soon as it leaves your hand.
Okay.
So if it's a dead type. Okay, so it goes down like that. It does go zero because it goes like that, right? For a parabola.
Microsoft.
Because highest is when you throw it, and oh wait,
The highest is when it reaches the peak in the air.
I wouldn't think you do it that way because
It says.
it doesn't prompt you.
So this is like.
Yeah, and I don't have,
Yeah.
So you have like.
I don't use anything that would give me a five.
I tried it on
Secured,
and it
starts
just
like-
don't work now, so.
Okay. Yeah,
that's
all right.
that's the word of
Thank you very much.
Now whatever this point is. It's.
Can acceleration be constant?
I don't think.
I don't think so.
gotten there. Yeah, I can't.
Acceleration is constant, yeah, so, I guess in this.
Because changing position is that. That's our changing position. Derivative of a position is velocity, so it goes like that.
Oh.
Derivative of velocity is a straight line.
It's not really defined.
I'm overthinking this.
Yeah.
Yes. Velocity.
Now the derivative
Like
of
you
this
would
graph
just
would
put
be like.
wherever the, like, position
It looks
you think is.
I got
Oh.
And if you don't think it's.
Oh, you can just back it.
Yeah.
There, so like,
That's what this graph would look like.
Position is in like.
yeah, derivative versus
That,
acceleration.
this is.
So.
Yeah, big conditions have position,
If the
function,
word is this big
velocity
around,
function.
Position is like,
Wait,
what I put as that is always positive. So I put from point A to point B.
Because you're still going up either way.
Oh wait, if they're just writing down the point, so it's not.
So then zero and negative would just be.
It's not just.
No, it is the one. Yeah.
wait, so acceleration was going slow the whole time. It was never increasing at any point.
For me, talking about it, like, it reaches that point.
But velocity.